This one is inverting amplifier. Find out the closed loop gain. Closed loop gain is represented by AF is equal to output voltage V naught by VI. Why it is called as inverting amplifier? Because VI is connected to inverting terminal, that is minus sign of the op amp. Therefore, V naught by VI is equal to minus RF by R1. V naught by VA is minus R1. Inverting amplifier introduces 180-degree space between input and output and input. Coming to non-inverting amplifier, the voltage gain for non-inverting amplifier is given by AF is equal to 1 plus RF by R1. 1 plus here AF is equal to say V naught by VA. AF is equal to V naught by VA is equal to 1 plus RF by R1. It is called as non-inverting amplifier because VA is applied to non-inverting. That means plus terminal of the op amp. That is the reason minus sign is not indicated here. AF is equal to 1 plus RF by R1. This one is a three-stage multi-stage gain. One is multi-stage gains. First one is non-inverting amplifier. Non-inverting means VA is applied to non-inverting terminal of the op amp. Second stage is inverting terminal, inverting amplifier. Input is applied to inverting terminal of the op amp, that is minus. Third stage is also inverting amplifier is applied to negative terminal of the op amp. Therefore, overall gain, multi-stage gain means A is equal to A1 into A2 into A3. When a number of stages are connected in series, the overall gain is the product of individual stage gain. That is A1, A2, A3 are individual stage gain. A1, we know that A1 is in non-inverting mode, therefore the voltage gain AF is equal to 1 plus RF by R1. A2 is in inverting mode, the gain is minus RF by R2. A3 is equal to minus RF by R2. Overall gain A is equal to 1 plus RF by R1. A2 is minus RF by R2 is minus RF by R. Therefore, these two are cancelled. So overall gain A is equal to 1 plus RF by R1 RF by R. Next one is inverting. Op amp important application is it acts as summer. This one is inverting summer. V1 and V2, these are the two voltages applied to internal, that means minus sign of the. And we know that individual gain V naught is equal to V naught by V1. V naught by V1 is equal to minus RF by R1. V naught by V2 is equal to minus RF by R2. Sum of these two. Therefore, V naught is equal to minus RF by R1 minus RF by R2 into V1 here into V2, input voltage. Therefore, common RF by R1, V1 plus when RF is equal to R1 is equal to R2 is equal to R. This one is minus R by R V1 plus R by R V2. Therefore, V0 is equal to minus of V1 plus V2. Input voltages are added V1 plus V2 with negative sign because this one is inverting summer. Remember these expressions. Output voltage V0 is equal to minus RF by R1 into input voltage V1 plus into minus RF by R2 into V2. Minus sign is common. RF by R1 V1 plus RF by R2 into V2. Here I1 and I2 are two currents enter into that node at A. I is away from the node. I1 is equal to V1. These are the B is at ground potential. A is also at the ground potential, 0 volts. I1 is equal to V1 by R1. I2 is equal to V2 by R2. I is equal to minus RF by V0. Minus RF by V0. Therefore, V0 is equal to minus sign here, minus RF by R1, V1, plus minus RF by R2 into V2. Remember this expression, V0 expression. Suppose this inverting summer acts as average circuit. This condition is satisfied with the two input inverting summer. R1 is equal to R2 is equal to R. R1 is equal to R2 is equal to R. RF is equal to R by 2. Substitute these values in that expression, output voltage expression. V0 is equal to minus RF is R by 2. R1 is R plus RF is R by 2. R2 is R into V2. Therefore, minus of V1 plus V2 by 2. Two input means sum of the two input voltage minus of sum of the two input voltages by 2. This is the average circuit. Coming to this one, the magnitude of the output voltage is the average of the two input voltages. The average of the magnitude means we use this one. Minus sign is removed. Therefore, V1 plus V2 by 2. Average of two input voltages. Suppose if the number of inputs are also increases, V1, V2, V3, and so on and so forth, Vn, R1, R2, and so on and so forth, Rn. In that cases, R1 is equal to R2 is equal to R3, and so on and so forth, Rn is equal to R. Rf is equal to R by N. In previous case, Rf is equal to R by 2 means two inputs. Here, two inputs. That is the reason we use R by 2. For n inputs, Rf is equal to R by N. R1 is equal to R2 is equal to R3 and so on and so forth. Rn is equal to R and Rf is equal to R by N. Coming to the circuit, first stage is inverting amplifier. Second stage is summing amplifier. In case of inverting amplifier, gain V3 by Vi. V3 by Vi or V1. This one is V1. Vi is equal to minus Rf by R1. Minus Rf by R1. Therefore, V3 is equal to minus Rf by R1 into Vi. Second stage is the summing amplifier. This summing amplifier means here V3 voltage here, this one is V2 voltage. Summing means therefore output voltage is equal to V0 is equal to minus RF by R3 into this voltage input voltage V3 minus RF by R2 input voltage is V2. minus of Rf by R3, Rf by R3. Here V3 is minus Rf by R1 into Va minus Rf by R2 V2. That is here we use my plus sign. Therefore, V0 is equal to, here minus sign is common one. V0 is equal to, here minus into minus plus, Rf square, R1, R3, Vi minus Rf by R2 into V2. In that way, we have to calculate output voltage V0. Coming to non-inverting summer, V1 and V2, this is the two input to non-inverting summer. V1 and V2 both are, these two voltages applied to that non-inverting terminal of the op amp through R1 and R2. Therefore, this one is Rf and R. This one is Rf and R. One more input is added here, V2. Therefore, V0 is equal to, generally V0 is equal to R plus Rf by R. That means 1 plus Rf by R by R1 plus R2 by R2. 1 plus R1 by R2 V1 plus 1 plus Rf by R 1 plus Rf by R1. This one is R1 plus R2 by R1. R1 cancel. 1 plus R2 by R1. Here 1 plus R2 by R1. Here RR cancel plus Rf by R. That means 1 plus Rf by R into V1. R1. Here R1 by this first case R1 by R2. Second case is R1 is cancelled. That is R2 by R1 into V2. This one is subtractor circuit. V1 and V2 and V0 are the output voltages. According to subtractor circuit, for applying superposition theorem, we consider only one input at a time. When only one source V1 is present, V2 is 0. Therefore, output voltage V0 is equal to V01. In that case, the subtractor acts as V1 is present. V1 is present. V2 is equal to 0. In that case, V0 is equal to V1. V01. V01 is equal to minus R2 by R1 into V1. Next, case 2. V2 is present. V2 is present. V1 is equal to 0. V2 is present. V1 is equal to 0. Therefore, V0 is equal to V02. Therefore, V02 is equal to 1 plus R2 by R1. 1 plus R2 by R1. R4 by R3. 1 plus R4 by R3 into V2. Therefore, output voltage is due to V1 and V2 are acting alone. V01 plus V02. That is, you write down this expression. 1 plus R2 by R1, R4 by R3, 1 plus R4 by R3 into V2 minus this one is R2 by R1 V1. R4 by R3 is equal to, suppose R4 by R3 is equal to R2 by R1. Both are equal, R2 by R1. In that case, V0 is equal to, this one is 1 plus R2 by R1. R4 by R3 is R2 by R1 by 1 plus R4 by R3 is R2 by R1. These two are cancelled. This one is V2 minus R2 by R1 into V1. R2 by R1 into V1. That is equal to V0 is equal to R2 by R1 V2 minus R2 by R1 V1. Therefore, subtracting voltage V0 is equal to R2 by R1 into V2 minus V1. Let the ratio of these two resistances R4 by R3 is equal to R4 by R3 is equal to R2 by R1. In that case, V0 is R2 by R1 into V2 minus V1. V2 minus V1. This is the subtractor circuit analysis. Next one is this one is instrumentation amplifier. Instrumentation amplifier. One is A1, A2, A3. A1 and A2 are, which consists of two non-inverting amplifiers. That means A1 and A2, and one difference amplifier, that is A3. That is A3. A1 and A2 are non-inverting amplifiers. Convert this one into non-inverting mode. A1 and A2 are converted into plus and minus here. Here R1 is changed to R1 by 2. R1 by 2. Here that is here. This one is R2. This one is V1 voltage. A1 is in access non-inverting mode. This is connected to ground. This is connected to ground. Inverting mode means already explained. This is the inverting amplifier. Non-inverting amplifier. R1 is connected to ground. RF here. VA is connected to plus non-inverting terminal of the op-amp. In this, A1 and A2 are non-inverting amplifiers. Therefore, VA is connected to non-inverting terminal of the op-amp. That is plus. R2 is the feedback resistor. R1 is connected to ground. Here, R1 is split into R1 by 2 and R1 by 2. Coming to next one, another op-amp here. This one is like that here. V2 is applied here. Here V2 plus sign. This is also A2 is also non-inverting amplifier. Minus sign here. Minus is connected to R1 by 2. R1 by 2. One more resistor is there. That is feedback resistor, that is R. This is V01 and this one is V02. Here both are in a non-inverting mode. Therefore, V01 is equal to 1 plus. We know that 1 plus RF by R1 into V1. Here RF is R2. Here RF is R2. RF is R2 by R1 is R1 by 2. R1 by 2 into V1. Therefore, V01 is equal to 1 plus 2 R2 by R1 into V1. And the same analysis is applied to here. Second stage, A2 is also A2 is in a non-inverting mode. Therefore, V02 is equal to again 1 plus RF by R1 into V2. Here RF is R2. RF is R2. R1 is R1 by 2 into V2. That is equal to 1 plus 2 R2 by R1 into V2. Therefore, V01. This one is V01 voltage. This one is V02 voltage. These two are obtained. The A3 is a difference amplifier. Difference amplifier or subtractor circuit. The ratio R4 by R3 and R4 by R3 is equal. Therefore, here V0 is directly V0 is equal to V02. Here V02, because V02 is connected to positive terminal. Here V2 in subtractor circuit, V2 is connected to positive. V2 is connected to positive. That is the reason V0 is V02 minus V01. Ratio R4 by R3 is equal to here also R4 by R3. R4 by R3. Therefore, V0 is equal to output voltage is equal to R4 by R3, V01 minus V02. V01 minus V02. V01 R4 by R3. V01 is equal to 1 plus 2R2 by R1 into V1 minus V02 is equal to R4 by R3 is also present here. 1 plus 2R 2R2 by R1 into V2. Therefore, V0 is equal to common term is R4 by R3, 1 plus 2R2 by R1 into V1 minus V2. V1 minus V2. This is the output voltage V0 of the instrumentation amplifier. In the last year, GATE 2023, this question is asked here. Observe this question. First one is Vin is applied to, let it be A1 and A2 and A3. Vin is applied to A1 and also A2. For A1, Vin is applied to negative terminal. For A2 is also applied to negative terminal of the op amp. Find out the output voltage V out by Vin. V out by Vin. This one is Vx. This one is Va. This one is Vx and this one is Va. First, we calculate Vx value. Vx is equal to this one is positive, this one is negative. This one is positive. This one is negative. One is negative. This one is positive. Here A1 minus plus. Here A2 plus minus. Here Vin is applied here to negative terminal here. Vin is applied here positive terminal. This one is connected to ground. R1. This one is R2. This one is R2. Both outputs are connected to. These are the two outputs, Vx and Vi. This one is inverting mode. Inverting mode. This one is non-inverting mode. Vx is equal to inverting mode op-amp gain. Closed loop op-amp gain is Vx by Vi. Vx by Vin. Therefore, Vx is equal to minus R2 by R1 Vin. Vy is equal to, here Vy is equal to, this op-amp is in non-inverting mode, 1 plus Rf by R1. Rf is R2, that is R2 by R1 into Vin. Vx and Vy are applied to summer circuit. This one is a summer circuit. We know that summer circuit, inverting summer circuit Vout is equal to minus R4 by R3 into Vx minus R4 by R3 minus R5 by R3 into Vy. It is minus R4 by R3 Vx plus Vy. That is equal to minus R4 by R3. Vx is minus R2 by R1 Vin. Vy is 1 plus R2 by R1 Vin. Minus R2 by R1 Vin plus R2 by R1 Vin. Vin is cancelled. Therefore, minus R4 by, one is R4 by R3 into 1. Therefore, the answer is minus R4 by R3. Answer is A. These are the fundamental concepts which are very useful to solve the GATE exam problems. Please remember all the expressions for these circuits.